The sky at night, a mountaintop window on the cosmos, the view of infinity. And high above, space telescope, probing the depths of distance and time. Gathering images like this from the edge of the visible universe, a brilliant primordial jet streaming from a quasar. By comparison, a mere galaxy is minuscule, but better understood. A cloud-like collection of perhaps 100,000 million stars. Swirls and spirals, galaxies have condensed over some 15 billion years into the celestial patterns we see today. Encyclopedia Galactica charts the cosmos, setting the abundance of scenes like this against the utter emptiness of the universe. Pictures and data gleaned from space probes and the most powerful instruments on Earth. And new theories, one on galactic evolution. Here a photograph of two galaxies in close encounter. Modeled on computer, they seem to unravel each other. It's clear in reverse how this cosmic kiss changes their shapes. Beyond, and galaxies appear as clusters, each point of light a group of galaxies. These vast strands encircling unimaginable voids are the structure of the universe. Our own galaxy, the Milky Way, is an unremarkable spiral. Old stars at the center, younger ones in the outer reaches. Within the galaxy, these are the stars themselves, each dot a sun in its own right, hundreds upon thousands upon millions. Closer to, and clouds of bright gas and dark dust as material billows from energetic new stars. Unlike the Sun, most stars are pairs or triplets. These three are the system Alpha Centauri. After the Sun, they are Earth's nearest stellar neighbors. Even so, their starlight takes more than 4 years to reach us. At 45 light-years away, the 6 stars of Castor, 3 sets of twins, all in orbit. Encyclopedia Galactica attends the birth of a star, a swirling cloud of gas and dust falling in on itself. As it coalesces, so temperatures soar. They trigger nuclear reactions. A star is born. And a star dies, its final breath a great nebula, the corpse a tiny pulsing neutron star. This photo of the Gum Nebula is the remnant of such a catastrophe. But its debris can recycle to spawn new stars like the Sun. Born 5 billion years ago, the Sun is just 8 light minutes from Earth. The local specimen of a rather ordinary type of star. X-ray reveals its nature. The Sun is a nuclear furnace, a turbulent colossus where every second 4 million tons of hydrogen is turned into helium. Encyclopedia Galactica cruises the planets, a journey through the 9 worlds of the solar system. To the red planet, Mars. A ride down Mariner Valley, 20 times bigger than the Grand Canyon. The contours are exaggerated, but this is virtual reality, volcanoes and all. These are the features of Mars interpreted by computer. The source, photographs and data radioed by space probes. Onward and outward to Jupiter and its many moons. This is the giant of the solar system, 2/3 the mass of all the planets combined. Time-lapse of Jupiter, among the most exotic sequences in the history of space photography. The camera was aboard Voyager, one of 2 robot explorers which have unveiled the outer planets. They photographed Saturn. Twin probes whose parting tryst glimpsed the beguiling Saturnian rings. As Voyager 1 spun away into the galactic void, Voyager 2 set course for Uranus. It revealed a cool giant with an intriguing moon, Miranda. Close up, Miranda was a symphony of contour, icy cliffs towering 20 kilometers or more. And around Uranus itself, Voyager detected a powerful magnetosphere. Four years later, and Voyager's final rendezvous, Neptune, another gas giant, and a place with the coldest surface in the solar system, Neptune's great satellite, Triton. And far beyond, Pluto with its moon, a mission yet to come. A flight over Venus. Of the inner planets, the Venusian surface has been the hardest to see, for it's enveloped by permanent cloud. Now, thanks to radar mappers, computers have visualized this, a ghostly topography, scuffed like an ocean bed. Venus, on the left, lies second nearest to the Sun. Tiny baked Mercury has the closest orbit of all. Planet by planet, Encyclopedia Galactica catalogues the pictures and the facts. It explores Earth as a planet. The collective satellite and computer data of NASA, the former Soviets, the Japanese, the Europeans. Above all, Encyclopedia Galactica places our beautiful, fragile world within the immensity of the universe. From the Big Bang, the formation of the galaxies, to the evolution of this planet Earth. And practical guides, learning the night sky, how to use telescopes and cameras, where to go, what to do. Plus the story of manned spaceflight, not just the past, but plans for a mission to Mars and a return to the Moon. Stay with us after the break when we take a close-up look at the Sun, the powerhouse for all life on Earth. We'll be recreating the birth of our local star and our solar system, and bringing you extraordinary film of the aurora, eclipses, sunspots and flares on the Sun's surface. To understand the nature of planet Earth, we must study the powerhouse at the center of the solar system, the body that heats and lights our world, on which everything, including humankind, depends. The Sun. The Sun is a star, an enormous nuclear reactor generating prodigious energy. Swirling magnetic fields, dark regions called sunspots, and searing eruptions of flares and prominences. Triggered possibly by the shock waves of an exploding star, the story of the Sun began some 5,000 million years ago, a whirling cloud of gas and dust that became increasingly concentrated. Within the cloud was all the material necessary to form the Sun and the planets. As the cloud condensed, so its central gravity increased, a vast aggregation collapsing on itself. The densest material at the center became intensely hot and nuclear reactions began. An embryonic sun had formed. Meanwhile, throughout the rest of the cloud, great swirls of material were shaping the 9 planets of the solar system. Today, the Sun is middle-aged, one of the 100,000 million stars in our galaxy, the Milky Way. Compared to Earth, it's gigantic. With a diameter of nearly 1,400,000 kilometers, the Sun is over 100 times wider than Earth, 1,000,000 times the mass. Even sunspots are several times bigger. The secrets of the Sun are revealed in its light, beams that can be caught and analyzed in solar observatories. Sunlight is a rainbow of color, a spectrum. Break it down and dark lines appear, fingerprints of the elements which make up the Sun. And they give us other clues to temperature, speed of rotation, magnetic activity. Here, the red fingerprint of hydrogen. This time-lapse, which filters only red light, reveals a Sun composed 3/4 of hydrogen, 1/4 of helium, and rotating in 27 days. Surface temperature, 6,000 degrees Celsius. In imaginary cross-section, the temperature at the core is 15 million degrees. Every second, nuclear fusion turns 4 million tons of hydrogen into helium. The energy produced takes eons to reach the surface. A total eclipse is another aid to solar study. It displays the tenuous outer atmosphere of the Sun, the corona. This is time-lapse of an eclipse from Java. The Moon, in orbit around Earth, is passing directly in front of the Sun. Only when the eclipse is total will the corona appear. As totality approaches, a strange twilight descends. Observers have trekked from many parts of the world to witness and record. And there's a diamond ring corona, just ahead of totality. The Moon now covers the Sun. An exposure change, and with it, the full magnificence of the corona. We're looking at a halo of hydrogen particles extending millions of kilometers into space. Totality was to last 5 minutes, 7 seconds. Precious moments, for the corona is so sparse that it's glimpsed only when the glare of the sun is obscured. Yet another way of looking at the sun is in soft X-ray. The small image is the same picture in visible light. They show the intense activity of sunspots. Sunspots are probably caused by powerful magnetic force lines. They're tangled and distorted by the sun's rotation and by its churning surface, the yellow photosphere. In close-up, the dark areas are sunspots. The bright regions, thousands of heat bubbles, each measuring 800 kilometers. This sunspot appears dark because it's 2,000 degrees cooler than the surrounding photosphere. The center is called the umbra, its edge the penumbra. A group of sunspots. They take up to 10 days to form and 2 weeks to fade. In quiet periods, there may be no spots at all. These sunspots were filmed in 2 different wavelengths. Here in visible light, now in the red light of hydrogen alpha. Both show huge arcs bent around magnetic force lines. The whale's fin is a prominence, the silhouette of a gigantic billow of gas. And there's another. Such plumes lick right through the sun's atmosphere, the red chromosphere. This one in black is set against the bubbling photosphere, the sea of firestorms at the solar surface. Prominences can extend 1,000,000 kilometers, this one suspended in a magnetic arc. But the most spectacular phenomena are flares, eruptions with the energy of 10 billion megaton bombs. Bottom left, shock waves radiate from an exploding flare. Remember, the sun is a gaseous mass. Flares eject stupendous quantities of material at millions of kilometers per hour, energized particles hurtling outwards as part of the solar wind. On Earth, they can disrupt telecommunications, but largely they're deflected by Earth's magnetosphere, except at the poles. There they create auroral rings as the particles are drawn earthwards. From beneath, the result is spectacular, the aurora, charged solar particles reacting with the atmosphere like a giant television tube. From the interstellar cloud that formed the solar system came not just the sun, but the 9 planets. As the heat of the sun increased, so lighter elements were driven outwards. They'd form gas giants like Jupiter and Saturn. Heavier material nearer the sun condensed into the inner planets, including Earth itself. Our embryonic world whence sprang life and humankind. We are truly children of the stars. Next time in Encyclopedia Galactica, we visit the 2 small planets nearest the sun, the dry, cracked and cratered Mercury, and Venus, a searing hell with temperatures to melt lead. Book your seats for a virtual reality flight across their surface. Also, we look back at our own planet, the Earth, from outer space, with satellite pictures showing seasonal changes and visual evidence of the hole in the ozone layer over the South Pole.